Right? This is example 4 at the bottom of 741. So let's see. If we want to convert from rectangular to polar, I would graph it first. You'll see why this becomes important. Okay. Negative 1, 1 is second quadrant right there. Okay, so I need to know what is the radius here. How am I going to find that? Well, you could probably just figure it out without having a conversion, but you could also use the x squared plus y squared equals r squared, right? If that's true, then that means that r is the square root of x squared plus y squared. So just plug in negative 1 and 1. R is the square root of negative 1 squared plus 1 squared. So r is the square root of 2. Okay, how do we find the angle? Use the tan. Right? Tan, if you know x and y, that's all you need to use that tangent formula. So we could say tan theta equals 1 over negative 1. So theta is tan inverse of negative 1. Okay, if you put that in your calculator, what do you get? You could do degrees or radians. Do degrees, because you would recognize degrees. You wouldn't recognize radians. Say again? It gets you negative 45, right? Negative 45 is down here. Remember that when you do an inverse, tangent is only going to give you values in these two quadrants. How do I find the angle that has the same value of tangent in this quadrant? You add pi, basically, right? I mean, what is the radian measure for that angle? 3 pi over 4. Right? So theta equals 3 pi over 4. I mean, that's why you have to be careful that you're in the quadrant you expect to be. Whenever you use inverse functions, it doesn't necessarily put you in that quadrant, right? Yeah. Figure it out? Okay. This next one, you don't even need the formulas for this. If you graph this point, you'll see the radius, you'll see the theta right away, right? Right, 0, 2. Right, that's this point right here. Okay, what's the radius? It's 2, right? R is 2. What's the angle? 90 degrees, which is pi over 2. So there it is, right? 2 pi over 2. Same thing.